Hello, welcome to another very hot day here in the UK, where I'm going to try and solve this puzzle which has been sent in by one of our viewers, Florian Zellmer. So big thanks to him. I hope it'll be a good puzzle. You can see it looks like a sandwich Sudoku, and it sort of is, but with a little twist on the rules that I'll explain in a moment. Florian is a new puzzle setter, so this is only the second puzzle he's ever created, and he started to create them because he watched Mark's video on how to create sandwich Sudoku. So anyone who's not seen that and has a penchant for getting into puzzle setting, do take a look at it. I'll link it in the video now. Now the twist in this puzzle, so remember in sandwich Sudoku all of these numbers outside the grid tell you the sum of the cells sandwiched between the 1 and the 9. So let's just do a quick example. If this 18 row here, if there was a 1 here and a 9 here, the 18 would be telling us that these three cells have to sum up to 18. And of course, you know, it could be the other way around. Now the important thing about this variation is that the puzzle is now going to be treated as toroidal. Now what do I mean by that? What I mean is that these sums are always taken from the 1 going for a crossroads, always going to the right of the 1, and for down columns always going below, down from the 1 initially. Now what this means is that we can introduce some more possibilities. So let's imagine that the 1 we thought might be here in row 5. Then to make the 18 count, we're not counting this way, we must strictly count this way. We sort of come out of the edge of the grid here and back into the grid on the other side. So if the 9 was, let's use an example, let's say the 9 was here in row 5, then this 18 count would be this square, and this square. And I think we're going to have a bit of flexibility, especially those of us who have done a lot of sandwich Sudokus, in order to get our heads around this, because my phone's ringing, hang on a sec. Okay, so let's just check that we understand it. Let's look at the down row as well. So if the 1 was here in a down column, then this 17 would be counting down from the 1. So 1, 2, 3. The first place a 9 could be would be this square and this square. Now we're going to have to. This is going to be interesting. So these 35 rows, which would ordinarily be where I would start in a sandwich Sudoku, because of course that would imply that the 1 or the 9 must be in the extremities. I don't think that's the case for this puzzle. No, because this arrangement would be completely valid for the 35 sum, because counting rightwards from this 1, we would include all of the digits. Blech. Right, this is going to be interesting. Now, if you want to try the puzzle, click on the link under the video, and that'll take you to exactly what I'm seeing here. Right, well I can see this square, that the 0 here means that this must be on the phone still. Okay, so now with any sandwich Sudoku, we must make sure that we highlight all the cells that can't contain 1s and 9s. And I guess in this variation it's the ones that are very useful, because this 1 here, because it can't have a 9 above it in its column, means that we can treat this like a normal sandwich Sudoku clue. So we need at least 4 cells to make 26, and this can't be a 9 either, because if this was a 9, this cell here would have to add up to 9, and obviously that would lead to a repeated 9 in the column. Why do I say it would have to add up to 9? Well, it's because, let me show you, if I put a 9 in here, we know that 1 plus 9 is obviously 10, plus the cells sandwiched between the 1 and the 9, so these cells would have to add up to 26, so 1 plus 9 plus 26 equals 36, and we know the total of a column in any Sudoku puzzle will be 45, because that's what you get if you add up the numbers from 1 to 9. So we'd have a repeated 9 there, and that doesn't work. So we know one of these two squares is a 9. And oh, now this one is more complicated, isn't it? Because the 1's going to have to be, so this is going to be a toroidal one, and the outies here, so the cells that aren't sandwiched between the 1 and the 9, are going to have to sum to 10, because obviously 25 plus 1 plus 9 is 35, 45 minus 35 is 10, so 10 can be either 2 squares or 3 squares. So if it's 2 squares, this would be the 1. If it's 3 squares, this would be the 1. So the 1 is in one of these two positions in this column. Ah, now look, there's something interesting here. This square, look, can't be a 9. Because if this square is a 9, because it's in a 35 clue, the 1 would have to be to the right of it. It would have to be here in order to allow us to include all those cells within the summation. And this square cannot be a 1. Ergo, this square cannot be a 9. That's lovely. So this is a 9. And that's going to allow us to do a little bit more pencil marking or green squaring at least. So 9 could be as many as 3 squares. So it's either 2 or 3 squares. So if I put the 1 here, that would work. So the 1 is in one of those two positions. And all of these positions must be green. There's a 1 in one of these two squares. None of these 1s correspond with 35 clues. So whichever one of these is correct will force a 9 in one of those two positions. So there must be a 9 in one of these two positions, and that means we can put small green squares in. This certainly doesn't have the feel of a puzzle that's somebody's second puzzle ever. This is already a lot. It's very clever. Right, so what can we do with this? This 3, that's been hanging there, hasn't it? That must be, we've got 3 in the column, so that must be 1, 9 like that. That's going to allow us to, that allows us also to get rid of this as a possible 1, so that is useful. This must be the 1 now. Now that means with this 9 total, we've got 3 cells now that add to 9, so they must be 2, 3, and 4. We've got 9s in one of these two squares and a 9 here, so there must be a 9 in one of... we can work out which as well. There must be a 9 in one of these two positions by simple Sudoku. But we've got the 1 here and a 4 in the column. So this square must be a 4, and this square must be a 9. And that gives us all of the 1s and 9s in the top right-hand 3 by 3, so we can... One of those squares can be a 1, obviously. This square can't be a 1. This 4 actually interacts on our 9 sum. Neither of those squares can be a 4. This is a 4. And the 3 here actually resolves that that's a 3 and a 2 in that order. It's quite rare in a sandwich Sudoku to be able to put in any digits that aren't 1s and 9s. If they aren't singles. So this is already quite surprising. 9, phone's still buzzing. 13 clue here, so the 1 must be here because 13 must be at least 2 cells. And as the 1 is at the top of the column, we know that those 2 squares at least must be green. This square can't possibly be a... can this square? Yes, this square could be, because the outies would then be 14 in 2 cells, which is possible. So, okay. So what next? We know there's a 9 in one of those two positions. And there's a 9 in one of these two positions. This can't be a 9 here. There's already a 9 in the row. Ooh, hang on. This 21 is now forced, I think, because... Is that right? Yes, because if this is the 9, that would force the 1 to be here. Now, before we got this 2, 3, and 4, that would have been possible, because these two cells could have added up to 14. But now, with the 4 here, that's not possible. So this cannot be a 9. Good Lord. This is a 9. So, I still don't think we actually know which of these is the 1, though. Ah, but now this can't be a 1, because that would mean that this clue should have been a 0. So this is not 1, so this is 1 down here, which means this is a 1. Oh, this is a bit of a sort of... It's doing my head in this, because it doesn't obey any of the normal rules. Well, you have to think about it very differently to normal sandwich Sudoku. So this is green now. These 4 cells add up to 18, obviously, and the 18 here, is it possible that 5 cells? No, that 5 cells isn't possible. So the 9 is in one of those two positions. Ah, now this 9 here we can use. This can't be a 9 anymore, so the 9 must be at the bottom, which means this square is green. Therefore this must be the 1 to make this 35 clue work. These two squares are green, obviously. This square is green. Let's tidy all that up. And right, okay, so now there must be a 1. Well, there must be a 1 and a 9 here. We know the 9 must be to the left of the 1, so this cannot be a 9. So these two squares are 9s, and one of these two squares are the 1s. Oops. So look now, we've isolated the 9s into column 4 and 5 now, in this box and in this box. So this square can't possibly be a 9, otherwise we've got too many 9s in those two columns. So this is a 9. Now this cannot be a 1, so this must be a 1, this must be a 1, and this must be a 9. That is so cool. Therefore this is a 9. So I think all of that is true. Now let's get rid of my OCD by making sure we colour in all of the cells that are not 1s and 9s. And now we're on to the Sudoku bit. So let's see how we can do this. Right, there's only one gap between this 1 and 9, so we know that the cells to the right of the 1, all of these highlighted cells add up to 29, plus 9 plus 1 is 39. This square must be a 6, not a 3. So when I put this 6 in, it gives us a 3 here. This 9, look, we've already got a 3 in that sum, that's a 6 therefore. This is a 6 because of Sudoku. So these numbers down here, therefore, are 5, 7, and 8. Let's highlight those and have a think about them. Oh, we can't do much with that. No, the 35 totals are so open-ended that we need to... So we've used this, we've used this, we've used this. We haven't... Oh, haven't used this yet. Oh, how about this, though? Ooh, look at this logic. This doesn't come up in normal sandwich Sudoku either. Got a 17 total here. Now that means we can isolate the value of these 3 cells, because they have to be 45 minus 17 minus 9 minus 1, which is 18. So these cells add up to 18, and these 2 cells sum up to 9. So the 5 highlighted cells there sum up to 27, plus 1 plus 9 is 37. These 2 squares sum up to 8. I'm going to have to find some way of recording that. I'm going to change the colour of those These two add up to 8. This is part of a 21 sum. These two therefore sum up to 13. Is that useful? Yes, it is useful. Look, these two sum up to 13, and these two sum up to 13 as well. So within this box, without using a 9, we must have two other sums that sum to 13. So these four cells must be 5, 6, 7 and 8, because it's either a 5 and an 8 and a 6, or a 6 and a 7. That is lovely. Now this 3 is down here. That's the only place a 3 can go in the box, and this must be a 2, 4 pair. And there must be a 3 up here. But we've got... But these 3 cells are the cells between the 1 and the 9 here. So 21 in 3 cells is 6, 7 and 8. So there must be a 3 in one of those two positions. Can't quite tell which. This is an amazing puzzle. This can't be a 6. Maybe I'm not sure what I have to do next though. So these 3 cells are 2, 3 and 5 in some order. Threes. Can I do anything by normal Sudoku rules, I wonder? These cells here must be 5, 6, 7, 8. Yes, we can. Look, that 4 therefore must be here in this box. That does, these two add up to 8, so the 4 doesn't really affect those. 2, 3, 6. Sorry about this, but this is quite a complicated puzzle. It's a lot more involved than I was expecting. So let's have a think about this. Right, so these 2 cells must be outies adding up to 10. And this cell, obviously it can't be 6, 7, 8. This must be, this must only be 2 or 4, because we've already got a 3 here. Therefore this cell is 6 or 8, I think. So if this is 2 or 4, there must be a 2 or a 4 up here. In fact, there must be a 2 or a 4, 2 in one of those 2 squares because of the 2's in these 2 positions. It doesn't help with the 13, and it doesn't help with this one either. Bother. Okay. So, but we've got 26 here. So this square and this square must add up to 9. And this square is a little bit restricted, isn't it, perhaps? Because it can be 2, what can it be? It can be 2, 3, 4 or 5. 2, oh, hang on. 2, 3, 4 or 5. Oh, not that one. Oh, well, this one can't be 4. Let's just amend this one. 2, 3. Hang on. This one in theory could be 5, 6, 7, 8, I think. No, not 8, 4. 4, 5, 6, 7 or 8. Come on, get it right, Simon. So this now can't be 4 because of the 4 here. This can't be 5, therefore. So this is 2, 3 or 4. And this is 5, 6 or 7. Oh, Lord, this is very difficult. Oh, hang on, this 22 maybe. Can I use that? So these 3 cells are outies, therefore, in this row. So they have to add up to 13. So this 8 here would be impossible. Because if this is 8, these 2 cells have to sum up to 5 without using 1. So 1, 4 is not in. Without using 3, so 2, 3 is impossible. Therefore, this cannot be 8. This must be a 6. Therefore, this is a 4 now. This is not a 4. This is not a 5. 6. 4, so there must be a 4 up there. And these two cells have got to be 2 and 5, because we can't use, we know they add to 7, they can't be 1 and 6, they can't be 3 and 4. Ah, now these two cells I said sum to 8, so this must be 3 or 6. And oh, we've got a 2, 3, 5 triple now in this 3 by 3 box, so this must contain a 3. One of these two must be a 3, therefore this is not a 3. This is a 2 or a 5. 2, 3, 5. So these squares are 4, 7, and 8. Wow. 18. 7, 8. Ah, one of these two squares must be a 4. I wonder if we can do anything with more with... Ah, yeah, 4. Maybe I could have done this before. Look, must be a 4 here. So this square up here is a 4. 4. This is not a 4. I think we've done most of the 4s. Don't really know much about where the 4 goes in this box. This 18 sum, can we do anything with that now? It's going to be these 3 squares that have to sum to 18. Ah, yes we can. This square can't be a 4, because then these two would have to add up to 14, and given the options here, that's not possible. So this is not a 4, this is a 4. Meaning this is a 4. One of these two squares must be a 4. This is 7 and 8, so this must be a 3. 3. Now I've got 2, 5 pair here, 2, 5 here. And these squares must be, what's that going to be? 2, 4, and 5? I think so. So this is a 2 or a 5. This is 2, 4, or 5, which goes with this. So we've now got a triple in this. Wondering whether I can use uniqueness. You always have to be a bit careful with uniqueness, though, in a sandwich Sudoku. So uniqueness would be telling me that this couldn't be a 2-4 pair because of the 2-4 pair up here. But let's not use uniqueness. Let's continue on our merry way and see if we can do it a different way. So now I feel like I'm being very slow again. 2, 3, 4, 5, 4, 6, 7. What is the next plate? Oh, these two squares must be 7 and 8, therefore. Okay, let's put that in, see if that helps. 2, 4, 7, 8. So the outies, let's have a look at the outies then in this row. So if I know these 4 squares add to 18, plus 1 plus 9 is 28, plus this 4 is 32. Ah, so this has to be a 5, because I know this square and this square have to add up to 13. So that's maybe the next place that we needed to look. That gives us a few things immediately. 8, 8. If this can't be an 8, this can't be a 5. I suppose I could also go eliminate 6 and 7 there, just in case it's going to require that sort of level of elimination. This isn't a 7 anymore. This must be, now this must be 8. It's the only place an 8 can go in the column. Delete 8s from those two positions. This must be a 2 or a 5, and there's a 5 there, look. So 2, 5. Now this 2, 4 finally allows us to realise this must be 5 and 3. And as this 13 sum now doesn't include a 5, we can remove 5 and 8 from the possibilities, and we're only left with 6 and 7 like that. Let's remove 6 and 7 from this 13 sum at the top, so that must be 8, 5 now. Oh, I don't like this. Why have I got 2, 4 here? Is this resolved? This could be resolved actually by one of the Yes, it's going to be. Look at that. Isn't that beautiful? So we know these two squares sum up to 9. So the options here are, oh no, hang on. The options for this square are 5 and 7. Well, 5 isn't possible, so that's how the uniqueness gets dealt with. 2, 4, this should be a 6, I think. This 2, 4 now is resolvable. This is a brilliant puzzle. I mean, it's really weird to me how much this messes with my head. I obviously solve a lot of sandwich Sudoku. You know, we've just released an app on how to, on exactly this form. So I'm very much in practice, but this still has been a real challenge and a very good one. So this is 2 and 7 now. So this must be a 6. This is an 8. This should be a 5, I think. And this must be a 2 and a 3 pair, which must now resolve itself this way. This is a 2. And are we? I think we are on the. It certainly feels like we're on the right track now. So this square must be a 7, I think, because we have a 6 and an 8 already in the row. So that must be 7, 8. It'll all resolve itself like that. This now can't be a 6 or a 7. Looking for 3, 5 and 8 down here. So this must be a 3 or a 5. This must be 3, 5 or 8. 7 resolves over here though, so we can all sort that out. What a puzzle. Okay, so now let's just finish it off hopefully. So these two squares must be 5 and 6. Looking at the column, we have a 6 there. So 6, 5, 7. 6, 7 means this must be 8, 8, 5. We're left with 2 and 3. Check. It looks good. So I haven't checked all of the arithmetic. I'll leave you guys to highlight if I've made an error, but I thought this was brilliant. What a brilliant puzzle. It's taken me ages. Let us know how you got on with it. Well done, Florian. Amazing that that's your second puzzle ever. I look forward to more of your work in the future. Thanks for watching. Enjoy the content. Please subscribe. We really appreciate it. Back soon with another edition. Cracking the Cryptic.